Back in 1997, Dave Cineage created the Linux Router Project, or LRP. It was a networking-centric mini distribution of Linux, and is described as small enough to fit on a single 1.44 megabyte floppy disk, and makes building and maintaining routers, terminal servers, and typically embedded networking systems next to trivial. The Linux Router Project is known to be one of, if not the earliest embedded Linux distribution, meaning it booted from some type of disk, loaded everything into RAM, and finally pulled the configurations, which were usually stored on a flash or floppy disk. It meant the operating system itself was stateless, or in other words, had amnesia. It would apply the configuration stored on the floppy or flash on every boot. So, changing the state of the router meant writing a new configuration file to the floppy or flash. The Linux Router Project enjoyed wide success until the second half of the year 2000, when money was running out. Of the near $4,000 needed at the time, Cineage had gotten less than $1,000. And the costs kept growing. The last releases of the 2.x series, 2.9.7 and 2.9.8, were released on July 29th and September 12th of 2000, respectively. Version 4.0 was slated to begin development the very next month. While Cineage was looking for cash flow, various new projects based on the Linux Router Project had been brewing for many reasons, including the 4.0 rewrite. One of which, in October, was the Linux Embedded Appliance Framework, or LEAF project. It was started by Charles Steinkuehler and David Douthit. Two of the more popular versions were Oxygen and Eigerstein. Oxygen was meant as an enhanced version of the Linux Router Project, version 2.9.7, with better package management, a fix for log overflow problems, and a new TFTP boot feature. Eigerstein specialized in easy setup of complex firewalling and DNS caching. These versions had lots of features or setups that just never showed up in the Linux Router Project. Up until January 2001, Cineage continued work on LRP 4.0, with not much to show for it. Cineage was unhappy with it, to say the least, because it wasn't shaping up to be any different than the 2.x series he had previously been releasing. So he began creating proof of concept work for 5.0, after abandoning 4.0 outright. But by this time, everything was way behind schedule. What should have been released in the summer of 2001 was barely showing any progress at all. Cineage was aiming for perfection. A new shell, a new scripting language, a new packaging system, full application management, and of course, dropping sysv init for a brand new init system designed by Cineage himself. But in January of 2003, after the Leaf project and others had been gaining popularity over the past 2 years, Cineage admits to himself the Linux Router Project was done. It wasn't until June 22, 2003 that a public announcement was made. But most people knew it was coming. With LRP 4.0 abandoned in alpha and work on LRP slowing to a halt, the will, the code, and the money was just not there. While Dave gave up on LRP as a career, the Leaf project was still there, turning heads and ready to take the lead. The admins that hadn't already made the jump would end up using Leaf, one of its branches, or some other project entirely, like GNAP, the Gen 2 network appliance. GNAP, as its name suggests, sprang from the same need as LRP and Leaf, but using Gen 2 as a base. In November 2004, the 0.5 version of GNAP was released. 1 year later, in August of 2005, while working for a nonprofit company on VPNs and firewalls, and finding that no existing solution perfectly fit, Natanael Copa, announced a new distribution on the linux.leaf.devel mailing list. He noted that, "I have been working on a proof-of-concept distro lately that I would like to describe as something in between GNAP and bearing uclibc." And bearing uclibc, by the way, was a specific branch of the Leaf project that used the bearing kernel and uclibc, a much smaller C library as compared to glibc, which focused on saving disk space. Copa's proof-of-concept distro was codenamed Alpine, and uclibc would be the C library. A new fork of Leaf was born. Alpine originally stood for a Linux-powered integrated network engine. The idea was that the distro would be focused on networking and be a tiny engine or framework to build bigger systems on. The earlier versions are a little cloudy, but we see Alpine 1.4 being developed in 2006, 1.5 in 2007, and Alpine 1.6 released on April 30th of 2007, and the switch to development of 1.7 in the days after. In 2008, October 18, while the 1.x branch of Alpine was still in full swing, we can see that already work was beginning on Alpine 2.0, with the first commit labeled Added BusyBox. In 2009, February 5th, Alpine 1.8 was released, and September 30th, Alpine 1.9. 1.9 is the first version of Alpine that ships with OpenRC and has the ability to install onto hard disks, features that we still see today. 2010, late February, early March, sometime in there, Alpine 1.10 is released and is also when the team learns their distribution is being used on servers. And shortly after, on April 9th, a new website is launched with a bit more styling than the plain text of the previous site. August 21st, Alpine Linux 2.0 is released and brought a new uclibc that broke ABI compatibility with older versions. If you wanted your binaries to work with the new native POSIX thread library, you'd need to recompile. November 1st, 2.1 is released and is the beginning of a tighter, 6-ish month release cadence, but with minor releases as necessary in between. 2011, May 6th, 2.2 is released with initial GNOME support, SHA-512 password hashing, and better disk partitioning. November 1st, 2.3 is released with the new Linux kernel 3.0, unbound DNS resolver, and encrypted LVM boot support. In 2012, May 3rd, 2.4 is released with better network, bonding, and VLAN support. November 7th, 2.5 is released with kernel 3.6.6 and GR security patches already applied. GR Security is an independent security company that, at the time, wrote security patches for the Linux kernel. 2013, May 17th, 2.6 is released with Kerberos over NFS support, Pixie booting support, and the inclusion of a new technology that had been brewing since 2008 called containerization in the form of Linux containers, or LXC. As containerization was taking off in other spheres, mainly Docker, earlier in the year, Alpine was a perfect fit with its minuscule memory footprint and fast boot times. No other Linux distribution did it better at the time, and that was what the industry demanded. From here on out, Alpine is a mainstay. June 20th, the team announced, "We are recently receiving more and more support questions from users, but our infrastructure does not provide any place for them. To provide an easy way for users to contact each other and Alpine Linux developers, we have set up Alpine Linux Forum." The earliest posts were mostly about getting Zen working and, of course, about the progress of Alpine 2.7. On November 8th, 2.7 itself was released as a normal upgrade and contained new versions and bug fixes, but nothing groundbreaking since the focus was now on 3.0. And on June 4th, 2014, Alpine 3.0 is released, and UClibc is dropped in favor of Muscle libc. Just like the 2.0 release, recompilation of old source needs to run its course again. This release also marks the beginning of ARM support, though no usable releases are available just yet. December 10th, Alpine 3.1 is released, and so is the first release built for the Raspberry Pi. 2015, May 26th, Alpine 3.2 is released and included the Mate desktop. December 18th, Alpine 3.3 is released with big renames of the editions that already existed. For instance, Alpine became Alpine Mini, and a new ISO taking the old Alpine name included more packages to support installations where network wasn't always available. The community repository is also created during this release cycle, containing packages from, you guessed it, the community. 2016, May 31st. Alpine 3.4 is released with support for running within VMs, better DNS support, and running on the Linux kernel's long-term support release 4.4. December 12th. Alpine 3.5 is released, and this marks the first version to drop OpenSSL for LibreSSL. As a result of the massive bugs found in OpenSSL back in 2014, including the infamous Heartbleed. It also included ZFS on root support and Python 3 improvements. 2017, May 24th, Alpine 3.6 is released with support for 64-bit PowerPC and IBM Z systems. Z? Z. Couple days later, as a side note, Postmarket OS, an Alpine-based Linux distribution focused on smartphones like the PinePhone, Librem 5, and others, has its first release. November 30th, Alpine 3.7 is released and now supports EFI and Grub within the installer itself, making installation a whole lot easier for folks wanting to see what Alpine is all about on real hardware. 2018, June 26th, Alpine 3.8 is released as one of only 2 releases that are released within 1 year, but brings with it NetBoot on all architectures, support for the Raspberry Pi 3, and the end of support for the last GR Security hardened kernel. 2019, January 29th, Alpine 3.9 is released with improved Grub support, initial support for the newish ARM v7, and the backtrack, like so many other distros, to OpenSSL. Many of the vulnerabilities that caused the initial switch had been addressed, and over the years since, many more eyes were constantly on the code. June 16th, Alpine 3.10 is released with LightDM for login and display management, which shows a renewed interest in running Alpine on the desktop. Also, IWD replaces WPA supplicant but is missing Extensible Access Protocol, or EAP, support for now. And this is important for enterprise deployments of Wi-Fi.
Oh, yes, it is.
December 19th, Alpine 3.11 is released with Raspberry Pi support, initial GNOME and KDE Plasma support, and the addition of Vulkan, DXVK, and the Rust programming language. In 2020, May 29th, Alpine 3.12 is released with support for the D programming language. And on December 29th, Alpine and others just do it better. So Leaf sees its last stable release at 7.0.1. 2021, January 14th, Alpine 3.13 is released and comes with official cloud images for services like AWS, Cloud Init, and better Wi-Fi support on the software side. June 15th, Alpine 3.14 is released with failed to ban, taking a back seat to SSH guard because it failed to ban. And ClamAV is now community supported. November 24th, Alpine 3.15 is released with kernel support compression using gzip. GNOME 41 and Plasma 5.23 land and disk encryption is now supported right in the installer. 2022, May 23rd, Alpine 3.16 is released, and the last release of this history. With better NVMe support, adding SSH keys at boot, a new admin user creation process, and a new setup-desktop script for desktop environment installation. And that is where the history ends.